robot for this presentation that is not up yet, but will be right now.
Hey, it worked.
So now we're going to go into hardware because when we are programming, what do we program?
The software
And what does the software use?
on the hardware.
Yes. Okay. Perfect. Okay, guys. So, Cedric, take it away. You're explaining this.
Take it away. What? I just got pushed on me. Okay. So basically, our entire electronics component, is generally called our control system, includes all of the important systems, like all of our motors and everything that controls our motors, and like our main computer and everything. And the way that the specific components that everyone uses can change depending on the team. Like you can swap out different motors, different motor controllers, but the general structure is the same, and there are some key components that will always be there.
Yes. Okay.
You want to talk about the Robo-Rio?
Yes, I love the RoboRio. Okay, guys. So RoboRio is a very important part of the robot. Okay. So I don't know if everyone can see it, but I'm gonna take this off so everyone can see it. Do we have a RoboRio?
In there?
Colin is holding up a RoboRio right now. Everyone look at Colin.
Oh my goodness.
Actually, look at Cedric. Okay. The RoboRio is the brain of the
show.
robot. Yeah.
Yes. This is Robo-Rio.
Essentially, it is where the main functioning and processing unit. It's where code is stored and run, and it is essentially kind of like our brain. It communicates with other components, like our body does with our other extremities. It controls motors, sensors, servos, etc. So essentially, we would write code on our computer. We'll go into more of how this works and how code is deployed and transferred. But essentially, code from our computer would directly go to the RoboRio, and then the RoboRio would transfer it to the rest of the body or the robot. Does that make sense, everyone? Questions about that? Perfect. Okay, moving on.
So motor controllers. We touched on this quite a few times, but they basically are the things that control. Who could guess? Our motors.
Wow.
Shocking.
Horror.
So basically, it helps abstract away all the stuff with how you actually tell a motor to do what it needs to do. Can you help try something?
No.
Oh, you're sure? Okay. So, for example, we have Spark Maxes, Victor SPXs, and Talent SPXs, which are all types of motor controllers that people have used in the past. On OD, for example, we mostly just use Spark Maxes, but it basically abstracts away all of the nitty-gritty with how you specifically command a motor to do an action, like all the voltage and stuff, and it consolidates that all into very nice methods that we can use.
Perfect. Okay, now we're talking about the gyroscope, which I also love. The gyroscope is located typically on top of the RoboRio. If you guys can, you guys want to stand up, I guess, or come.
I'll also-
Everyone come around.
Also bring the computer.
Come around.
Let's
come
look at the
around.
computer.
Gather.
Go on in, Wyatt.
Yeah. Do you want to see it? Why you see it?
Okay. So if everyone wants to gather around the robot, there's this purple thing right here, and it's our gyroscope. So typically, there's a Pigeon X, there's a Pigeon 2 and a Navix 2. Essentially, those are two types of gyroscopes. We use the Navix. Essentially, this is how the robot keeps track of its location, its different orientations, etc. So this time it's oriented level to the ground, but in other robots in the past, like Grasshopper,
And
and
Melman.
It
And
is
Melman.
up against the wall.
yeah. So the
On the outside.
gyroscope is is mounted upwards, so that means that we have to adjust for that in the code. But overall, we just know that the gyroscope is how we find different information regarding headings, that kind of thing. Yep. So everyone take a seat. We're done sitting. Perfect.
We're done.
We're done standing. My bad. Okay.
We're not done for the day. We are
Not
done.
yet.
Okay.
sleeping.
I'm sure you guys all. Cedric, you take it away.
So LEDs are something else we might be working with during Geek Week, but it's basically a way that we generally communicate with our drivers about certain states of the robot. For example, this year we had our LEDs be red or green depending on if we have remote or not, and pretty much it. It just lights on the robot. You can make him look cool. It can make your robot look really cool, but it's also very nice for certain functionalities.
Exactly.
Yep. You generally program it as a whole LED system instead of just one LED at a time, but you can't do that too.
Perfect. Okay. Okay. So we're talking about something else.
Okay. Okay. Well.
We're talking about this.
Yeah, let's
So when we write code on, what do we write code on? Raise your hand, Keegan.
VS Code.
Exactly. So when we write code on VS Code, how does it get on that robot? How does it get in the matches and do all this stuff? Raise your hand if you have any guesses. Just throw out your best guess, guys. Patrick.
I've heard the word deploy before, but I don't know what that means or how to do it.
Oh my gosh, that's so right. So essentially, we have something on the robot that is currently on the floor.
They get this. You get knocked loose.
Yep.
Oh, of course.
Um,
And
it's so
what's that thing called?
It's called a radio. So there's a radio on here. It's just stuck down there.
We'll try to make it easier next year.
Essentially, the
Put
radio.
all the pneumatics on top of it. Yeah, I'm not grabbing that.
Yeah. So the radio is essentially how the robot. Ryan, it's okay. What are you doing? Essentially, it's how the robot communicates with the driver's station and with the computer as a whole.
It's just us.
So,
Oh, I'm still recording.
when we have code, we will typically pull up the little Wi-Fi thing like you would do when you're connecting to like the 525 Wi-Fi here, and you would something would pop up called 525 OD. I think it's called. Yeah.
It depends on your robot. And you can configure it yourself. But
Yes.
Since we call our robot OD, we configure it to do 525.
Yeah. So essentially, we would just connect to that, and when we are connected, we can now do something like Mr. Patrick said called deploying. So that's essentially when we take the code on the computer and through the Wi-Fi network and the radio on the robot, we can send code to the RoboRio, which we talked about earlier. So essentially, there's a command on VS Code. We'll go over this later. You guys will have the chance to do this, but you'll do Control-Shift-P. There's something called, and you click deploy. There's a button. You'll see it later on. But essentially, when you click deploy, the code will be sent, and now once it loads fully, and it'll come up on the terminal, which I'm sure you guys are all familiar with. But the terminal will say deployed successfully, I think, or built
It'll say
successfully.
built successfully, and then
Yeah.
you'll hear the robot beep,
Yeah.
and it'll be very cool.
So that's how the robot now has it. And when you are not okay, so let's say you're in the middle of a match and the radio gets disconnected. What would but then we want to change some code, so we deploy. But what would happen if the radio is disconnected?
We won't get the code.
Exactly. So the radio is essential in doing that. Anyone have any questions about that? Perfect. Okay.
Do we want to show an example of like where the menu is for deploying, like in VS Code?
I have not opened VS Code yet, so I would,
Yeah.
if that's on the menu, I'd love to see what
Yes.
it
Yeah,
looks
we
like.
can show it. We can show it.
Okay. So I'm just gonna go here. Okay. So this is what all of you guys downloaded. It might not have the code right now, but this is kind of what you'll see every single time. So right here on this sidebar is really important. Can you see that? Okay. Okay. So you're always gonna be typically right here on this thing that kind of looks like paper, kind of a little bit. It's called Explorer. You're gonna click into that, and that's how you get to over here. It might be closed, but you can open it, etc. But overall, you kind of have this kind of structure and stuff. Like we said earlier, you're gonna have your like commands over your subsystems. That's kind of something we talked about when formatting. Then you'll have your constants main robot container out in the middle because it's weird. But essentially, yeah. When we were talking about deploying earlier, we are not connected to OD right now because when we go to the Wi-Fi over here, OD does not pull up. Why does OD? Okay, question, pop quiz. Why is OD not listed in the Wi-Fi right now? It's the radio is connected, but why is it not showing up, Joshua? Exactly.
Exactly.
So in order for the radio to show up here, we have to have power. So let's say we have power all connected. we would do Control Shift P, and that would pull up all these different things. Some of these are not very important. You don't have to memorize them, but there are different actions you can do within VS Code. And then the main thing that pops up is deploy. So if I click deploy right now, what would we think would happen if we're not connected?
Nothing.
Exactly. So we're not going to click it, but you guys got it. So that's essentially kind of the basics. You'll have the chance to work with this a lot more, but this is where we write all of our code and where the magic happens. Any questions?
I found it.
What?
So deploy. I don't have any files, but I found where it says deploy.
Yay!
Yeah.
And you guys can experiment with all this stuff. As long as you when we're actually writing code for the season robot, we don't want to be playing around. But this is Geek Week is an opportunity you guys learn and explore. So feel free. Yeah. You guys are we good to move on?
Any questions? No.
Okay.
No, we can probably.
We're gonna skip the end.
Oh my gosh, it's
Oh my
Advantage
gosh.
Kit.
Okay, so this is a topic that Eden is very, very, very passionate about, and it's Advantage Kit, and it's very auxiliary based. So
It
let's let Eden take it away.
Okay, guys, where do I even start? I love Advantage Kit. So basically, Advantage Kit is how we do. It's the way. It does a lot of things. Okay, let me start over, guys.
Let's start with Advantage Kit and then Advantage Scope.
Yes, you're right. Okay, so Advantage Kit is a form of data logging and software where we can simulate different things. We can do a lot of things. It might be a little bit easier if I go and look into Advantage Kit and pull it up. Advantage Kit, FRC. But essentially, it directly impacts how we have structured our entire code base this year. So, essentially, okay, it's responsible for logging, telemetry, and replay. So, let me just list these off so I make sure I go over all of them. So, one of the main things that we use it for is logging. So, when we are in a match, right? Can everyone see this, or should I move it over here? Move it? Probably I want to move it, right? I'm moving it. Okay. So one main thing we want to use it for is logging. So in a match, let's say we our autonomous does not work at all. We run an autonomous where we want to go from this point A to point B right here, but it ends up turning around and going into the driver's station. We do not want that, right, guys? So first of all, does everyone know what logging is? I assume that. I should not have seen that. Does everyone know what logging is?
Not like with wood.
Yes. So essentially, logging is kind of like taking, in the context of FRC, it would be taking data and saving it to a different external source so that we can look back on it later. So
recording of all the things that happened in the match to find what went wrong.
Yes, exactly. So in that match where it went into the driver's station, we could look back on the log data we saved and see what was the motor doing there. Did we command it to do something we didn't want to? Is there an error with the computer, the gyroscope? We can see all the different values and see it really helps us a lot with troubleshooting. Does that make sense to everyone? Kind of the basic reason why we have it. Another reason we can do it is for replay. So this is something we use a bit less than logging, but another big use of Advantage Scope is that we can replay matches directly.
What is Advantage Scope?
Advantage Kit. We're not talking about Advantage Scope yet, guys. My bad. I got ahead of myself. So Advantage Kit is essentially one of the main things is replay our matches. So when we go through a match, we have a bunch of values. There's different interactions. So the motors are doing all these things, all this stuff. And we can save all of this information onto a file. Then after the match is done, let's say we don't want to look at the data. We want to replay the entire thing. We want to see it again so we can have a closer look at it. Because let's say our whole drive team was looking at something else. So we didn't really know exactly where it went. So we can, with Advantage Kit, we have the capability to replay it exactly as it happened. So we can look and replay that data on our computer through something called Advantage Scope and see that in what happened. Advantage Scope is really, really cool. It's something that goes along with Advantage Kit typically, not this. But it is where we can visualize all of our data. If
You
I can
want scope
find
or
it.
kit?
Kit Scope. I think so. Yeah, okay. Cool. We found it, guys, don't worry. Anyways, so it's where we can see all this logged information. It's where we can replay stuff and all of that thing. It takes a bit to load, but essentially there are many different views that we can pull up. So right here we have a line graph. This is a very basic thing where we can display data. So you might have like motor, left drive motor. So right here you could drag it over here. You can put it on the left axis and you can see what values during that match it was displaying. You can also display a lot of different other things. You can do the 3D field. In this, the 3D field will pop up and you can take your odometry or your robot's position and you can replay exactly where it was during that match and you can see exactly where it went. This is also really useful for autonomous testing. So, and one thing that we use this year is we use this a lot when we did not have access to the robot or a full field. So we're able to see where is this going to go? Do we need to adjust it before we actually get access to the robot? So it's really useful. Overall, Advantage Kit and Advantage Scope are super, super useful for testing and getting stuff done before we actually have the robot. So does anyone have any questions about the concept of that so far? It's a little bit hard to wrap your head around at first, but it makes more sense once you actually use it and work with it. Questions? Cool. I'm talking a lot, Cedric. Do you want to take over for a little bit? Or are you good?
This is kind of your deal, Eden.
You're right. You're right.
You should,
Okay.
you should be talking a lot.
I'm still going to talk then. Anyways.
If you want me to say anything, I'm glad to, but
Yes, what's up?
Do you want the rest of the model for? Because I have the files.
No,
for the
we're-
full
should be
OD.
fine.
We're good. We have that saved. It's just not in this computer and project. So we're good. Thank you, though. Okay. So we have that. So the question is, how do we do this, right? It's kind of complicated and it took me a while to wrap my head around it personally, but we'll go through it step by step and we'll make sure you guys all understand it. The main thing how we do this is within the structure of our subsystems. We talked about subsystems earlier. What is a subsystem?
anyone remember?
Keegan.
It represents the functional motors or parts of the robot.
Yes, exactly. So let's take a simple example. Let's go with climb. Okay, so right here we have our climb subsystem. Notice how many files does it have?
4.
Exactly. Yes.
I can count.
Okay. So the first file we have is climb.java. This is an example of our subsystem within the 4. Within our Advantage Kit structure, there will be 4 classes to every subsystem. At least 3 or 4, most of the time 4, sometimes 3. So the first one will be our subsystem class. The next one will be our IO class, or what does IO stand for?
You want to have a guess? Like it?
Yes.
Is that?
And this is not, and I should be more specific. What does this say right here? Wait, my bad. One sec. What does this say right here?
Class.
Exactly. This is a class. But what does this say?
Interface.
So,
That's different.
It
yes,
is different.
it is different. Does anyone know what an interface is?
Not a class.
Usually a thing that a person would interact with in order to interact with a machine. It's an intermediary between a person and a machine.
Yeah.
Like a user interface.
Yes.
That's one case.
Yeah.
That's correct in the terms of generally, but in Java it has a different meaning.
Yeah.
But you are correct.
Yes.
Interface.
Technically correct. That's not correct.
What?
Who- I have a question.
Yes.
Who here has pets? All right, I'm gonna ask, who of you are cat people? Who of you are dog people? cats and dogs can be described in kind of the same way, right?
Okay.
Because what was the first question I asked? Who has
Pets.
They're both
Cat-
pets.
cats and dogs are both pets, right? Cats and dogs both have how many legs?
Four. Unless.
Unless.
It's typically four.
Usually 4.
Cats and dogs can also both speak and drink water and
Play.
play, right? So the whole job of an interface is to describe common, in Java, an interface can only describe behaviors, it can't describe attributes. But the whole idea is that the interface describes common behaviors that objects that might be completely wildly different from each other have in common. So cats and dogs, no one's gonna look at a cat and think, oh, that's a dog, right? Probably. Same thing with the dog, no one's gonna think that's a cat, probably. But there are a lot of similarities that they have, and an interface allows us to sort of generalize what it is we're working with.
Okay, so another thing we have is a sim class. Does anyone have any guesses for what sim stands for?
Simulated?
Yes, exactly. So this is exactly how we simulate our classes and stuff, and it's responsible for what allows us to go into advantage scope and replay that. And then 4 is our hardware class, which represents our hardware objects and all those things. So now we're kind of going to go over into what all these classes mean, because so we have all of these make up one subsystem, right? But like, why? Like, why can't we just have one giant class for them? And like, what does each part do, right? So let's start with the easy ones first. So sim class, you guys kind of already said it, but it
Simulates.
exactly. So we're kind of sectioning it off into its own place where simulation only occurs. It's where we create, in this class, it's where we create the simulated motors. It's where we store simulated values. Almost everything in here is dedicated purely to simulation. If you guys don't understand what all this code means, that's completely okay. It's kind of advanced, but yeah, does that make sense? Okay, the next one is going to be our hardware class. So this is the Victor SBX. This is our motor that we use for the climbers when we had.
That was the motor, yeah. That was the motor controller that we used for our climbers when we had snowblower motors, which we no longer have, but
That's okay. So essentially, the hardware class is the purpose of it is to define hardware. It kind of like it's like in its name. We assign ports here. We initialize hardware objects. It's essentially where we can say we want to use this hardware. It's going to be this port. It's going to be this, this, and this. It's where we just declare those kinds of things. Does that make sense? Okay.
no questions.
Cedric, do you want to take IO?
Oh boy. Like we talked about before, I/O is basically the interface that both sim and hardware fall under. It is basically defines what our hardware or simulated hardware can do and what we want it to do. So generally in our I/O, we will define the methods such as, for example, I believe we have set power or set voltage in there or set position. I believe set voltage though.
Yeah.
Like yeah, set left and right volts, which will be shared with both of our sim and hardware class, as well as something called, I believe, inputs. We have update inputs, and we'll also. This is also where we define all of the inputs that will actually end up logging.
Yeah.
So we have a very nice. I don't remember what it's called. The very nice tag. It's called @autolog.
I think it's annotation.
Annotation, yes, that is the word. I believe that's the word. So basically, the Advantage Kit sees @autolog, and basically it autologs all of these values, and these values are actually adjusted and changed in each of our I/O classes depending on which one we're using. So if we go back to either one of those, we'll see that in the update inputs, we will be updating each of those inputs, wherever it is. Yeah.
It should be similar.
Yeah.
Okay. One important thing to note is that IO. Okay, first of all, let's go over Climb. So Climb is our main subsystem class. It's responsible for like the logic. It uses everything kind of. It kind of like if you had to like, it kind of uses all of these here, and all of these work together to use here. Obviously, kind of more complicated than that, but except for this one, most of the time, it's usually just these two, right? Yeah. Okay. My bad. Anyways, so essentially, the hardware that we declared and initialized, so the motor, the first left motor, etc., and the IO class where the outline is of these variables that are currently have no values are used and assigned logic here. So like specific, like right here we can see in order to stop, we create a method where we set the volts, where we use the volt, my bad guys, let me lock in really quick. So essentially the motors we created in the hardware class and the empty values that we created in the IO class are used here, and we set that we combine those two and we set it to 0 when we want to stop. And then this method is called whenever we want to obviously stop the climbers. Essentially, this is kind of complicated. It might not make sense right now, and that is completely okay. But just, we're going to keep this up here so you guys can reference it back. But this is essentially how we set up our code. It'll make more sense later on. So if you're like really confused right now, it's okay. Just stick with it. You'll be okay. And one thing that is important to note for this specific project is that auxiliary is mostly going to be working on simulation, whereas
Core will be working more with the actual subsystems and the IO hardware classes.
Mm-hmm. Because that's more on robot, whereas simulation is obviously not.
There's more to the projects than just that, but that's generally how we will divvy up the creation of each subsystem.
Mm-hmm. Yes. So this all encapsulates one subsystem. Yeah, as we already said. Okay. This is a lot of information. If you guys have any questions, are you confused about anything? Want to go over anything again?
I feel like I just got like fire hosed with information a little bit.
Yeah.
And I think that it will make more sense once I actually start to see
Yes.
things. Like I'm glad to have heard all the words, so when I hear them again in context of a thing,
Yes.
I'll be like, oh yes, that's a word I have heard.
Yes.
But I don't even know what questions I have.
Mm-hmm. That's
And
completely.
I wanted to say that just in case anybody else was feeling that way.
Hi.
Hi. Yeah.
Thank
Yes.
you.
You're
This-
welcome.
This is like the only day when it's gonna be like this. Tomorrow and the next couple of days will be purely code based. We'll obviously have like instructions and all of that stuff and helping you. But this is just the first day to go over information. The rest of the days you'll be on the computer, you'll be typing, and we'll help you through it. So if you guys are confused, just come back these next couple of days and you guys will be able to write some awesome code.
Woo. Is there anything else we want to cover today? I know that we kind of went through multiple days of stuff, so
Yeah, you guys, I applaud you guys. You guys cooked tonight, guys. Good job.
thumbs up, everybody. I just want to make sure, are there any other things we want to cover today? They're whispering again.
I did. I did.
They're whispering again, Craig.
I did.
Okay. I'm not having real time.
Whispering is better than screaming.
Oh yeah, that's kind of important, guys. Okay,
Yeah,
guys.
oh, yeah.
So.
no, it's just a remembrance.
Guys, Cedric called me out. Okay, so basically when we're using Advantage Kit and Advantage Scope, we are able to simulate in real time as well. We don't have to just go back in and like look back on things. We can have it happen in real time. So let's say our gyroscope is giving us trouble for some reason. Our robot is doing different things than we command it to. So like it might be turning this way when we wanted to turn it this way and command it to go that way. That kind of thing. That's one way we can look at that and see why and what's happening under the hood is to actively log the gyroscope heading while it's moving. So then once we see that, we can compare, okay, we're commanding it to go turn to like 20 degrees or whatever, but it's saying that it's going this way and it's going to this. Is this a good example?
I have a question.
Yeah. I don't know what example
So
is.
I think most of you have written an amount of code in the past, right?
Mhm.
If your program isn't working quite right, how do you typically figure out Like what's wrong? Good.
I had a bunch of print statements.
Print statements. What if you could print a line graph?
Ooh, that would be fun.
In real time.
Wow.
That's what Advantage Scope is. You can take print statements and make them look way easier to read than text on a journal.
Yeah, for example, last year during our scrimmage Corn Dog Classic, one of our
Swerve drives.
very, very nice swerve drives was missing a key. So I believe it just didn't
Didn't turn the way it was
record
supposed
how
to.
it was turning correctly.
It's like a really bad caster wheel. So
Yeah.
if we tried to go straight, it would turn. It's like if you're in
Have you
a
ever had
swivel chair, but it's one of the bad swivel chairs that we got from the old high school. You try to push it straight and it turns that direction.
Oh.
Like a bad shopping cart.
Oh.
It screwed up autonomous and screwed up basic driving principles.
Yeah, so via Advantage Kit, we were able to see that we were commanding everything the correct way. And we were also able to see physically with our eyes that it was very much not doing what we were telling it to do.
So we knew it was a hardware problem.
And we were able to eventually be able to figure it out and look into the actual third drives and figure out the problem that was missing a key.
Don't worry, we have a checklist. I promise.
But yeah, that's a real world application or FRC application
Yes.
that we actually were able to use that for.
Okay.
Yay.
Any questions? You guys did so good today. Everyone should give themselves a round of applause.
Yay.
You guys survived day one.
So we'll be back again tomorrow.
Yeah.
Yes.
So we are going to end tonight's session a little early. So if you need a ride, you should text your mom or whatever. I'm going to stop recording. So text your mom or whatever is going to go on the YouTube video. Love that. And we'll see you here tomorrow.